Hi, my name is Kirman, and for a final year project, a working prototype of interactive media was designed for the Department of Electrical and Computer Systems Engineering. Keeping the idea of engineering interactive resource development in mind, our presented prototypes comes into a distinct but an integrated form of an interactive video and a website with the common purpose of establishing a common link between the units taught by the faculty and their real-world applications. After 2 semesters of planning and plotting, the education resources were developed, keeping the element of interactivity in mind.
Hi, my name is Moin, and I'm working with Kirman on this project. I was responsible for making the interactive websites, and Kirman did the interactive videos. Now, we mainly worked on 3 different ECSC units, namely Signals and Systems, Electrical Energy Systems, and Engineering Electromagnetics. Now, we actually developed these prototypes under the supervision of Dr. Jonathan Lee, who was our supervisor, and the whole purpose of this project, I guess, is to make sure that the aspiring engineering students don't get intimidated by these units. And so we provided a simplified engineering education resource for them. In this video, we have divided the unit segments into 3 different categories. So we start off with Signals and Systems. We go over the interactive website and videos and describe them for you, and we repeat the process for the other units. And we finish the video with our concluding remarks, and we hope you enjoy this video. Thank you. Thank you.
We are now at the landing web page for Signals and Systems. We start with a brief introduction to this unit and guide the users to potential areas of future study with these button prompts. We then move on to the importance of signal processing and use the small example of noise elimination from a signal as one of its applications. It is followed by general information about the unit, such as prerequisite knowledge, which are these first year units, followed by additional resources. This video right here is the second education resource developed for this unit. My teammate Kirman will go over the video a few moments from now. Overall, this is the basic layout for each of the units that we worked on, and this was done to keep the design clean and ergonomic. Moving on, we will now go over a simple application of signal processing, namely signal filtering. In this example, filtering techniques such as high-pass and low-pass filtering are applied to a pre-recorded audio file. What's interesting about this example is that the students get to directly interact with the website and understand the differences themselves. I will now play the original audio file.
Hello, 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 check, check, check.
Now I'll move on to playing the high-pass filtered signal of the original audio file. Right, and finally playing the low-pass filtered signal right now.
Hello, 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 check, check, check.
As you can see, the user is able to clearly distinguish between audio files. The high-pass filter only filters out the high-frequency components, and the low-pass filter only filters out the low-frequency components of the audio file. To get a visual representation of these changes, the user can also click on this button prompt right here and get frequency plots for each signal. So here we go. As you can see, the signals can be distinguished easily based on their appearance and filtering technique. This topic overall and much more along with it will be discussed in great detail further into the unit. Finally, we are now at the landing web page for engineering electromagnetics. Now that we've gone through this generic template a couple of times, let's move on directly to this example. In this example, instead of focusing on an application, we focused on clarifying a fundamental law of electromagnetism, which is the Gauss's law of magnetism, also one of 4 Maxwell's equations. After briefly introducing the equation, its importance and general application, we can click on this button prompt and get to the next page. In this page, the equation of topic is showcased and the user can get a breakdown of the variables by simply hovering over the equation. Next, we have the vector field, and again, the user can simply hover over the term to get a simplified understanding of what a vector field is, and so that they can move on to the next section more easily. Now, in the next section, we have the same sequence repeated for divergence, and the user can again hover over this section and get the definition or the explanation for this term. And finally, we have the magnetic field, where the user can repeat the process and basically get a combined explanation and understanding of the previous terms and get a culmination of all that into this singular term, which further explains the original equation up at the top. This example is actually meant to attract aspiring ECSU students again to learn more about this unit, and this topic will be discussed in great detail again in this unit along with much more. We are now at the landing web page for electrical energy systems. Similar to the previous example, we start with a brief introduction to this unit, potential areas of future study with these button prompts, importance of this unit, followed by general information such as prerequisite knowledge and additional resources. Again, we have an education resource video right here, which will be covered by my teammate Kirman in a few moments. Moving on. We will now go over a simple example of the game-changing electric motors and how that is relevant to this unit. As you can see, by clicking on this button prompt right here, the user can be guided to a new web page that will contain more details about the induction motor. Right, we are now here to the next page. The user is greeted with the latest advance in Tesla cars that include autonomous driving. The user can use these button prompts to jump back and forth between each section. In the next motor section, the induction motor is described and how altering the frequency of the AC power supply allows the driver to change drive wheel speed, making the system reliable. The user can also hover over these highlighted region to recognize the induction motor correctly. Now moving on to the operation section. So now we have the components inside the motor, the stator and the rotor, and their functionality. And this is complemented with easy to understand animations, as you can see. Finally, we move on to the efficiency of the motor. Now by hovering over these animations, you can see that there's a tooltip which goes over how a induction motor is far more efficient, reliable, and has no harmful emissions, whereas the internal combustion engine requires more additional parts for rotational motion, is not as efficient as the induction motor, and causes harmful emissions. This example is meant to attract aspiring ECSU students to learn more about this unit, and this topic will be discussed in great detail in this unit along with much more.
For making interactive videos, we used an online tool called Powtoon. It is quite adaptable and easy to learn. Powtoon allows you to make interactive videos on many different categories such as education, work, and personal categories. You can either choose a given template or simply click on the blank template option and create your own template. All the features are located on the left hand side of the template. You can choose your own background and choose the titles and subtitles from the text option. You can also add images to your videos and can choose different character from the choices given. Other than that, you can choose any kind of props or specials that may be required for your video. In Powtoon, each slide has a maximum duration of 20 seconds. After that, you need to add a new slide. After the video is done, you can either export it to YouTube or download it as an MP4 format. For this project, we made 5 videos for signals and systems, engineering electromagnetics, and electrical energy systems. The first half of our signals and system video contained basic unit description, where we talked about the need to study this unit and what kind of things students are going to learn. Other than that, we also mentioned the prerequisite required and what are the difficult aspects of this unit. The practical application that we discussed was convolution in image processing, where we define what convolution in image processing is and discuss the basic principles behind its working. And we also explained how this concept is being used to solve real-world problems such as self-driving cars and planes on autopilot modes. For engineering electromagnetics and electrical energy systems, we made 2 videos each, where one video contained the basic unit description and in the other one we discussed about the real-world application of the particular unit. Unit description video is similar to as that of signals and systems, in which we talked about the concepts taught in that unit and few of the practical applications linked to it. For engineering electromagnetics, the real-world application we discussed was magnetic resonance imaging, also known as MRI. It is a common known medical application that people know about. In this video, we talked about how magnetic fields generated by MRI change the orientation of photons in the body and how this helps to produce body images, which can be used in diagnosis and disease detection. For electrical energy systems video, the real-world application we conversed about was that of light dimmers, in which we talked about basic engineering principles in the working of light dimmers and explained how average current flow affects the intensity brightness of the lamp. Our main aim was to link these units to their real-world applications, and we did that with the help of these videos. The objective that we set for ourselves at the end of semester 1 were conditionally met. Our objective at the end of FYP was to develop 5 working prototypes for different ECSA units, but we were only able to complete our work for 3 units. In retrospect, after discussing with the supervisor, we came to realize that we undertook more tasks than we could practically accomplish. But nevertheless, the prototypes that we have built have been received well, and we have received positive reviews overall for our efforts.